All right, so we are going to find area of regular polygons today. We're going to start off by labeling some things on this picture. The point inside a regular polygon that is equidistant from every single vertex, which are the corners of the figure, that is the center. On this figure, it is point C. I just realized I already messed up. I forgot to remind us what regular means. So if I want to know what regular means, it means that all of my sides are congruent. Okay, it also means that all of these interior angles are congruent, but you don't have to write that because it'll just muddy up your picture. But all interior angles are also congruent. Okay. Now, if we can imagine that we have, don't draw this either if you don't want your picture all messed up. If we imagine that we have a circle that is inscribing our figure, what is this guy? From the center to the edge of the circle, he's a radius.
Oh, yeah.
Radius. Okay. So it kind of makes sense if you picture the circle on there.
Yeah.
Oh, shoot. Okay. All right. We're going to skip over the third one for a second. The last one on here, the fourth one, has its vertex at the center, and its sides connect the center to consecutive vertices. So if you think about connecting the vertices to the center, and they have to be consecutive, that means one follows the other. So it has to go G to F, not G to E, because G and E aren't consecutive. Okay, so it goes like this. So that is a central angle. Okay, central angle has its vertex at the center and its sides connect the center to consecutive vertices. Okay, now we're going to talk about the one I skipped over. It's this cute little guy here. Okay, he connects the center of a side to the center, and he gives us the perpendicular distance from between those 2 points, and he is the apothem. And I saved him for last because he's kind of like the MVP. He gives us a whole lot of information, and he's going to be mission critical. He's got a lot of important jobs. One of his first jobs is that in addition to being perpendicular to the side, he also bisects the side. So he is a perpendicular, let me use a symbol. He is a perpendicular bisector of the side. Okay, he's got another job. You can see that all of the radii are congruent. So we have here, by hypotenuse leg, 2 congruent triangles on either side of the apothem. So he's also bisecting our central angle. Okay, and if we don't know those pieces of information, today is impossible. So that is super important. Okay, now we're going to go back to talking about the central angle for a second. So we have a pentagon here. For this pentagon, if we wanted to find the central angle, let's use the central angle DCE. The measure of angle DCE would be, imagine me standing in the middle of the pentagon. Okay, how many degrees can I spin to do a complete turn in the middle? 360, perfect. So I have 360 degrees around the center. Now, how many wedges do I have? 5. So I'm going to take my 360 degrees that I can spin and spread them evenly between my 5 wedges. So what does that give me for my angle? Perfect. So 72. So each of these is 72 around the whole thing. Okay, they're all congruent. I'm not going to write 72 5 times. That seems a little excessive. Okay. Questions so far? Okay, now the formula for any polygon that's regular is that you take the number of sides and you divide 360 with it. So n is going to be our number of sides, which kind of makes sense because number starts with n. Oops. Okay. All right. Now we're going to use some of these to find area. Okay. So if we want to find the area of this regular polygon with side length of S and apothem A, so the A is the apothem, the S is the side length, right? Okay, and then the N is how many what? Yes. Okay, perfect. We have to follow these steps. We're going to divide the polygon into n congruent isosceles triangles. So let's do that. I'm just going to go from vertex to opposite vertex and try to go as straight as I can. Okay, that was a little crooked. Nope, it was really bad. I did better this morning. I did it the best this morning, and it's been downhill from there. Okay. Okay. So in this example, I have 6 congruent isosceles triangles. So isosceles means that these sides are all congruent because they all have the same radius. All the radii are the same. Okay, step 2, we're going to find the area of one isosceles triangle. So I just took this one right here and put it right there. Yeah, so let's label it. So each of these is a side, right? Okay, so what's this?
It's one part.
Just the side length, right? Okay. And then if I draw in my apothem, you notice anything funny about that? Okay, well, yeah, it's just, yeah. Do you remember the area of a triangle?
Well, it's like,
Take a rectangle that's base times height, and then we only want half of it. So 1/2 base times height.
okay.
Okay, what is the base of this triangle? Yeah, it's S. It's whatever S is. So it's going to be 1/2 times S, and then what's the height? So the base is the S, the apothem is the height.
Okay.
So that will give us the area of one of these little baby triangles. But we've got more than one in this figure.
So we gotta find it.
Yeah, we got to times it. Okay, so in this particular example, we have 6 sides, but if we wanted to make a formula that would work for a figure with any number of sides, what could we use instead of 6? N. Okay, so for a regular polygon, whoops, it's going to be however many sides, because that's the number of isosceles triangles, times the area of one of the triangles. 1/2 times S times A. Which incidentally, if you look at option 1, is the first option for a formula.
Mhm.
Okay. What would the perimeter of this figure be? S plus S plus S
Oh, yeah,
plus
'cause
S.
we add them.
Okay, so how many S's do we have here?
6.
Which is
One.
N. So if we wanted a general formula for perimeter, it wouldn't be just 6S, it would be NS, yeah. Okay, so that brings us to option 2. If we know that perimeter is the number of sides times how long the sides are, we can replace the N and the S with a P. Okay, so these are 2 options. There's one more option which has to be my favorite, and it is area equals 1/2 NAS. Now, we would use this one all the time, but this isn't the one I get to give you for your formula sheet. The one that you will be able to use for your formula sheet is this one. So we are going to attempt to use this one, even though that one is my personal favorite.
Okay.
Okay. What else do we need to say? Nothing. We're going to do an example. All right. So what 3 things do we need to find the area?
Or
Okay, sorry, my N got a little bit tall,
N.
but that's an H.
Yeah.
That's not an H, it's an N. Okay, so we need N. So what's the N for our example? 1, 2, 3, 4, 5. Okay, do we know the apothem?
No. This is 8.
Okay. Do we know the side length?
Yeah. 12.
Okay. Now, if we know the N and the S, do we know the perimeter?
Yeah.
Careful, careful.
Or no,
What do we do with them?
we don't.
Times them. Okay, so the perimeter will be 5 times 12, which is 60. Okay, so our area will be 1/2 times the apothem, 8.2583, times the perimeter, which is 60. All right, let's go to the hundredths place. What did I do on the other notes? I did the thousandths. Let's do the thousandths. Okay, did you get this?
Mhm.
Perfect. All right, make sure you put it in square units because area is 2D, not linear. Okay. Easy enough, right? So this process is pretty easy when they just straight up hand you all the information. So the ones on the back get a little bit more exciting because it kind of looks like we don't have enough information. Yeah, we don't have the apothem. So let's write down what we do know. Do we know the number of sides?
Yeah.
Okay, what is it?
Is it 5 or 6?
It's 6. Okay, do I know the apothem?
No.
Okay, leave some room. Do I know the side length?
8.
All right. So I'm going to have to find the apothem before I can find the area. This does not work without the apothem.
Mhm.
So let's start by chopping it up into our congruent triangles. How many are we going to make?
6.
Yes. Okay, let's draw in our apothem. Okay, do you remember what the apothem's jobs are?
Yeah, you have it.
Uh-huh. What does it chop in half?
The family?
Yep. Okay, so if this whole side is 8, what is this bit and this bit?
4.
Yeah, these are each 4. Okay. Now, do I know any information about the radius?
No.
No. But I need another piece of information to be able to solve in this triangle.
Mhm.
Wouldn't it be nice if I knew what this angle was?
Yeah, is it
This one's 90, but not that one.
one's not.
Well, do you think that if I could find a central angle, I could just chop it in half and find this angle?
Yeah.
All right, so our next step is that we have to find the central angle. So I can rotate 360 degrees. How many wedges have I got to chop the 360 into?
6.
Yeah.
So 360 divided.
Yep. So I'm going to take the 360, divide it by 6. So my central angle is 60. So what is my chopped in half little baby angle?
30.
Perfect. Okay, now that helps a lot because we just turned this impossible problem into a 30, 60, 90 right triangle.
Mm-hmm.
Nailed it. And we have the short side,
Mhm.
which is the easiest one. So how long do you think the radius is if it's the hypotenuse? Well, it would be 8, right? It'd be double.
Mhm.
Okay. What about for the apothem? I did everything in red. I should not have. How do we go from the short side to the long leg? We multiply by root 3.
Oh, by root.
So our apothem is actually just 4 times the square root of 3.
Oh.
So all we had to use here was special rights.
Mm.
Okay. So, do we know the perimeter?
No, but we can
Okay, how would I find it?
times
Yeah, times what?
4.
Well, how many 8s do I have? 1, 2, 3,
so 8
4,
times
5. Yeah, 8 times 6, which is 48. Okay, so the area will be 1/2 times, what did they put first, the perimeter or the apothem? I forget.
It's
The apothem
Yeah.
first. Okay, so times 4 root 3 times the perimeter, which is 48. So this is the apothem, this is perimeter. It'd be a good idea to remember, label them so that when you go back to this, you know what it is.
okay.
All right, so I can do half of 48 and get 24. 24 times 4 is 96. So the exact will be 96 root 3
Okay.
inches squared. And then it's also wanting rounded to the nearest thousandth.
Oh, are we doing it without the root three?
Oh, I think I just messed up. I found a mistake in my notes. I was tripping when I did those. All right, so I got 166.277 inches squared.
I got that.
Okay, perfect. Yeah, I definitely messed it up on the notes. I magically turned the root 3 into a pi, and it totally changed my answer. And then I also rounded to the hundredths instead of the thousandths, so I'm not sure what I was doing. I don't know. All right, let's do another one. Okay, so we have to find the area of this beautiful regular pentagon. So, what three things do we need to know?
The N,
Okay, do we know the N?
no.
How many sides does it have?
Oh, wait. 5.
Okay.
Three.
Do we know the A?
No.
Do we know the S?
14.
Okay. Okay, using that information, do we already know the perimeter?
No. Yes.
What is it?
Isn't
5 times 14?
70.
70. Okay. All right, so I need to find the apothem. So let's draw in the triangles. Put your center maybe a little bit lower than you'd think.
Okay.
Not a lot of it, because then it'll be wonky, but a little bit. Okay, draw in your apothem. Now, do I know that I have a 30, 60, 90?
No.
Correct. Because I don't know what the measure of this central angle is.
Yes.
So I don't know what angle my apothem chopped in half. So I have to find it. So I'm taking my 360 degrees and I'm chopping it into how many pieces?
5.
Good. And it gives you 72.
Okay.
So when I chop that in half, what is the measure of this little baby? Yep. Okay, so let's go back to the side length. All right, this whole thing is 14, but the apothem does what to the 14? Uh-huh. So now I have
7.
a pair of sevens. 7 and 7. Okay, now 36 doesn't give me any special right triangles. However, I can use the opposite and the adjacent and my trig to find the apothem. Okay. So if I look at my 36-degree angle and I go straight across, the 7 is opposite that angle. The radius is the hypotenuse. I'm not going to use that. So the 7 is the opposite. Okay, the apothem happens to be the adjacent, but it already starts with A, so I'm just going to leave it be A. So which of our ratios uses opposite over adjacent? SOHCAHTOA.
Oh, yeah. Opposite.
Here, let me do it this way. Yeah, TOA.
Mhm.
Which is?
90.
Yes. Okay, so we're going to use this one. So the tangent of 36 degrees equals the opposite, which is 7, divided by the apothem, which is also the adjacent.
Yeah.
Okay. So the problem here is that our apothem is on the bottom.
We have to bring the second one?
Well, I want it on the top. So I'm going to multiply both sides by the a.
Okay.
So on this side, on the right side, it'll cancel. And then on the left side, it'll be in front of the tangent.
Okay.
36 degrees.
Mhm.
Now I want the a alone on that side. So how do I undo multiplying by tangent of 36? Divide. So I'm going to divide it away from this side, and it will be on the denominator of the right side. Now, if you can see that they just switched spots, that will save you a lot of time and energy in the future. You see that they just switched spots on the diagonal? Like if you put this over 1, they just went flip. Okay, perfect. So my apothem is 7 divided by tangent of 36. So let's put that in the calculator. I got 9.6. Are you in degrees?
Yeah, that's right. Yeah, I'm not.
Okay. So I got 9.63467.
Okay, I got that.
Okay, now here's the deal. If my directions are telling me to round to the hundredths or thousandths place, that doesn't mean in the middle of my problem. What happens is if I don't give myself enough decimal places, when I get to the multiplying part, my decimal starts moving to the right and I lose accuracy in my answer. Does that make sense?
Yeah.
Okay. So if they're asking you to round to the hundredths or thousandths, we want at least 4 or 5 decimal places. Okay. Cool. Where are we? We know the perimeter, we know the apothem, we're ready to rock and roll. What's the area? The formula is 1/2 apothem, 9 point, yada, 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 times the perimeter, which we said was 70. Okay, I think for that one, I got approximately 337.21. And these are square millimeters.
Yeah, I got that too.
Did I remember? Yeah. Okay, questions? So depending on our central angle, it might work out to where we get to use special rights, or we might have to use trig. Okay. All right, one more, we can do this. All right, what 3 things do we need?
The N.
Yep.
The N.
So do we know the n?
Yeah. 8.
Okay. Do we know the a?
No.
Yeah, we do.
Oh, we do?
Yep.
Oh, it's 6.
It's 6.
So the thing we don't have this time.
Yeah, we don't have the side this time. So we're going to have to do some hocus pocus to get the side.
Okay.
So let's start by chopping it up into our congruent triangles. Whoops. This apothem is a little bit crooked. I'm sorry. We'll just pretend like it's not crooked. Okay. So this time I still have the, well, I have like the adjacent side to whatever the heck this angle is.
So we're going to screen through this side.
That's not the side length.
Oh, okay.
Okay, so I need to find this bit
Yeah.
using this little triangle.
Yeah.
That'll be my x.
Mhm.
And then to get my side, I just say that 2x will be my side.
Okay.
I just double it
Mhm.
because it's 2 of them. Okay, so it all hinges on me finding this angle.
Mhm.
How do I find my central angle?
Okay.
Okay, I'm going to take my 360 degrees.
About the side. Right.
Yep, divide it by the 8 sides. What does that give me?
Mhm. 45.
Mm-hmm. Chop it in half.
I don't know.
Well, it's odd. It's not super pretty.
Oh, yeah.
It's like if you chop 44 in half, you get 22 and then a half.
Yeah.
So I already know that my apothem is 6. I want to find x so that I can double it. With respect to my 22.5 degree angle, what is my x? Opposite, adjacent, or hypotenuse?
Or is it opposite?
It's opposite. It's straight across. So this is the opposite, and the 6 is the adjacent, which is A for apothem also. All right, so which of our ratios uses opposite and adjacent? Yep. So we're going to use tangent of 22.5 degrees equals our opposite x over our adjacent, which is the apothem 6. All right, we want x alone. How do we undo dividing by 6? Yeah, we multiply on both sides. So that'll go away and it pops up as the coefficient.
Mhm.
Make sure that your calculator is in degree mode and you should be able to crank it out.
Is 2.48. How many numbers do you want?
Like 4 or 5.
Okay, so it's 2.48528.
48528.
Mhm.
Okay, now we have to double it because our side has 2 x's.
Mhm. So times.
Mm-hmm.
Oh, you want me to-
Yeah, I don't have it.
Okay.
I did it different on my notes.
Okay, it's 4.9705.
What?
4.9705. 97.
Are you sure?
That's what it says on here.
Okay, 4.9705.
Five.
One more.
6.
6. Thank you. Okay. All right, we got everything. All right. So let's plug it all in. Area equals 1/2 times our apothem, which is 6, times our perimeter. Our perimeter is going to be, this one's gross, so let's not. Let's just say the perimeter is 8 times the 4.97056. Okay, so this is the apothem, and this is our perimeter. Okay, I know I got this one right. 111, sorry, 119.29 centimeters squared. Okay, that's not too bad.
Yeah.
Okay, we survived.